so in this section we're looking to find the inverse of a few functions. Not every kind of function has an inverse, but if it's a one-to-one function, remember that it does. Okay. To find the inverse, remember we're just switching the roles of x and y. Now, when you're given a function in f of x equal to form, sometimes it's a little bit easier just to rewrite it instead of f of x as a y, okay, because then you can actually see the x's and y's. I usually draw a line here, right, because now we're going to indicate that we're going to write the inverse. And you can simply write the inverse by switching the x and y's. So y's become x's, x's become y's. Okay, so this is the inverse right now. It's not in the form we like it. Remember, we like it in y equal to form. So we'll subtract the 12, divide by -4, and we'll have our inverse function. So subtract the 12, divide by -4. So we could write it like this, x minus 12 over -4. I'm going to multiply top and bottom by -1. So it becomes 12 minus x over 4. Okay. So again, it's just nice when you start with f of x and you're finding the inverse to write it with the inverse notation. F inverse of x is 12 minus x over 4. Okay. Remember, if you look at the graphs, they should be reflections about the line x equals y, that diagonal line through the first and third quadrants. Okay. All right, so the next problem, again, it's given in h of x form. So first I'll just write it as a y. Okay. Again, nothing has happened there, just a little rewriting. So now when I write the inverse, the y's become x's, the x's become y's. So again, right here I have the inverse, it's just not in the form I want it in. So I want to solve for y. So I'll multiply to clear fractions. So I'll bring the y plus 4 up to the left side. And again, we're just trying to isolate the y. So I'll divide by x, subtract the 4. And I have my inverse. Now again, it's just nice if we start with h of x, then we'll write the inverse as h inverse of x equal to 3 over x minus 4. Okay. A couple more. So again, in number 3 here, we have the square root function. And again, if you graph it, you will see that it is one-to-one. It passes the horizontal line test. Okay, we're just going to be a little bit careful. I'm cautioning you here about watch domain and range, and we'll see why in a second here. Okay, but again, I just introduced the y, just to rewrite it. Switch the x and the y, and I have the inverse. Okay, now again, we just like to put it in y equal to form, and here's where you have to be a little bit careful. To get y by itself, the first thing we have to do is square. Now, squaring both sides tends to create, remember, extra solutions. Okay, so when I square each side, at this point I know I better check things at the end. Okay, but for right now, just continue, subtract 5, and I have maybe what's my inverse function. Okay, now why do I have to watch the domain and range? Well, remember, the graph started as the square root function, shifted left 5 units, so it's just back here. You should remember what the square root function looks like. If we reflect across the line, y equals x, we should wind up with something that looks like this. So this will flip over to here. Actually, I'll put it in a different color here. So this -5 will come down to here, right? The -5x becomes the -5y, and then we'll flip, and we should get something that looks like this. Okay. So again, this just graphically should be f inverse. Okay. So how is that different than what we wind up with here? Well, remember, this x squared minus 5 is clearly the entire parabola. We're only having the right side of it. So for my inverse function, f inverse of x, it is x squared minus 5, right? But only for x greater than or equal to 0. I'm only taking the right half of that. Okay, and again, the reason that shows up is because we needed to square each side. So that tends to create extraneous solutions. So all the points over here that I'm ignoring as part of the parabola arose because of squaring each side. All right, and then number 4, again, we have the negative square root. So again, a similar thing will happen here. So we shifted left 3 units, but then reflected across the across the x-axis. This is a vertical flip. So again, we shifted it back here. Right? So this is the graph we're talking about. And again, without even doing any algebraic work, we should be able to see that that negative 3 will flip. I'm not sure, I don't have a very good scale here, but I think negative 3 is actually down here somewhere. Okay, and then when we flip across the line, sorry, y equals x. All these points here in the 4th quadrant are going to get sent to the 2nd quadrant. Okay, and so it'll look something like this. Okay, so this one will be f inverse of x. Okay, so again, it looks like it's going to be the left half of a parabola. Okay, so a very similar thing happens here. Switch the role of x and y. Square each side. So you get x squared. I've seen the negative disappears when you square it, is y plus 3. Subtract the 3. Okay. But again, we have to be a little bit careful when we write our inverse function, f inverse of x. It is x squared minus 3, but again, we're only taking x's that are negative, or less than or equal to 0. Okay. And then we get the left half of the parabola that we need. All right, and then finally, for number 5, this obviously is a parabola, right? We know that. Parabolas would not typically pass the horizontal line test, so this would not necessarily have an inverse, okay? But again, keep in mind I have a restricted domain, so I'm not taking the entire parabola. So I shift right 1, okay? And again, this would be the parabola, but I don't have any of this before 1, I only have this part after 1. And again, that part after 1 clearly passes the horizontal line test. When I reflect across that line, I should get something that looks like this for the inverse. Okay. So again, I'll call this y equal to switch the role of x and y. And then remember, you're trying to isolate the y. So here we're going to have to square root. Now again, when we square root, right, it's plus or minus, and we'll have to figure out which one we need. I'll add the 1 over. Okay, but again, we can see from the picture that we want our y's, right, to be 1 plus the square root. It's going up. So our inverse here, g inverse of x, would be the 1 plus the square root of x.